Okay, number 5. So given that the function equals 2x plus 3 plus 12 over x squared, where x is greater than 0, show that when you integrate this function with these set limits 1 to 2 root 2, you get this answer here. You get an exact answer. Now to do this straight away, to integrate, you firstly got to make sure that all your terms are on the ground, that you have all x terms on the baseline and there is no fractions and such forth. So first things first, let's change 12 over x squared into something standard, yeah? So we can say that the function is now, of course, 2x plus 3. And now if we move x squared to the baseline, we can call it x to the negative 2. Because that's what we do. You raise it up, you just switch the power to a negative sign. Now, let's just integrate this, yeah? So integrating this function from 1 to 2 root 2, plugging this in. Well, what do we get over here? Well, this is easy, yeah? To integrate, you just basically increase the power by 1 and divide it. So 2x becomes 2x squared over 2. 3 is like x to the 0, so it becomes 3x to the power 1 over 1, which is the same. And the last one, 12x, it becomes 12x to the, if you add 1, it would be minus 2, it would be minus 1 over negative 1. And then we just put the limits down. 1 and 2 root 2. So what I would personally do is firstly try and simplify this, yeah? So inside the bracket, we're going to have x squared plus 3x, and this is going to be minus 12 x to negative 1, or bring x to negative 1 underneath, will be minus 12 over x. And then you put the limits in, yeah? Alright, so thankfully you can actually put this all in the calculator once, which is a good thing. If you put 2 root 2 at once, what do we get? So just to show in the exam, do it like this, yeah? So you can say when x is 2 root 2, so 2 root 2, you should get answer squared plus 3 answer minus 12 answer. You should get firstly 8 plus 3 root 2. You can put it underneath when x is 2 root 2. So always give a reason. And then the second one would be minus, and then when you plug in 1, so you're going to have 1 equal, so you can have 1 plus 3 minus 12. So you can get minus 8. So these are your two solutions. This is here when x equals 1. So it's always like that. It's always the upper limit minus the lower limit. And when you plug this all in, well, you can clearly see that 8 minus 8 is 16. And then you can have 16 plus 3 root 2. 16 plus 3 root 2. Easy stuff. Oh, not bad. Now let's move on to 6. Question 6. Let's go. So prove from first principles that the derivative of 3x squared is 6x. Okay. Now first principles, all that really means is that we need to use the definition of a limit. And one key thing to know is that when you take the derivative, it's always using dy over dx. In other words, the change in y over the change in x. That's always how we find a gradient. So think of the change in y and change in x as in two coordinates. That's what we have from x to something known as x plus h, where h represents, the extra distance. Same with the y coordinates. We've got fx and fx plus h. Now, to make your life easy, when you have this, put this formula down. So this is the difference between both the y's and the x. And the limit is always set to 0 because we need to think that the gradient is always a flat slope. Okay, that's why it's 0, because the gradient is a flat slope. Now, let's go ahead and plug and play. So if fx is 3x squared, that means f at the point x plus h is going to be the same thing, but replace x with x plus h. So let's go ahead and just do this step by step here. So this fraction, so fx plus h is going to be 3 times x plus h all squared minus fx, which is 3x squared, over, so we've got x plus h minus x, where the x is cancelled, you're left with h. Now, let's go ahead and try and tidy as much as we can, yeah? And the 3, we can factorize the 3 out. So just taking 3 outside, let's take 3 over h outside, yeah? So take out h as well outside, so we're going to make it clear, 3 over h. Now what do you have inside? So you've got x plus h all squared, so expanding this x plus h squared as a quadratic, you should get x squared plus 2xh plus h squared, and then you minus it against x squared. Okay, hope you guys are following. If you're not following so far, just remember this was over h, but I just took it outside, yeah? Now looking at this one, we can start simplifying this. So cross this out, so bang, bang. And you're left with 2xh plus h squared. Now what we could do is realize that we can, if we multiply 3 over h across, we're going to have 3 over h times 2xh, which will give us 6xh over h, where the h's actually cancel out. And lastly, you got 3 over h plus h squared, which is just, well, 3h, because 3h squared over h is 3h. That's it. Now we go ahead and apply the limit. So when we can say that when h approaches 0, 3h becomes 0, because remember, you just substitute h with 0 and you're left with 6h. So this cancels out. And that's it. We proved the definition of a limit from first principles.